Hello friends, welcome to Aditya Kumar Mathematics. In this video, I will give a trick to find out the number of bijective functions between two finite sets. First, we will discuss some concepts of bijective functions. Then, the shortcut method to find out number of bijective functions between two finite sets for solving problems. And we have to solve this question also. So now we will discuss the topic. So today's topic is bijective function and how to find out the number of bijective functions between two finite sets using shortcut methods within 5 seconds. Okay, and that shortcut trick will be helpful to solve such type of questions in all entrance and competitive examinations. So first we will discuss what is the bijective function. Also it is called bijection or one-to-one and onto function. A function f from a set A to B is a bijective function if it is one-to-one as well as onto. That means the bijective function means it satisfies conditions of both one-to-one function and onto function. In other words, we can say like this for a bijective function, it is one-to-one, that is fx equal to fy, which implies x equal to y for all xy belongs to A. This is the condition of one-to-one, and already I made videos to check one-to-one function. You can watch these videos for more concepts and more tricks. And the second condition is onto. For all y belongs to B, there exists x belongs to A such that fx equal to y. That means every element in the codomain has pre-image. And also I made one video about how to check onto functions and how many onto functions between finite sets. You can watch these short tricks to improve your problem solving skill. Now I am going to give some examples. You see, between two finite sets A, B, some arbitrary elements I am taking and mappings also I am giving here. Then what about the first function? You can see that 2 and 4 has one image point. Okay, actually the one-to-one function says when image point is the same, that means elements are also same. Or if you are taking two different elements, then it must have two different image points. But here we are getting the opposite. We are taking two different points, but we are getting same image point. That means it is not one-to-one. Since it is not one-to-one, obviously it is not bijective. Because bijective means it must satisfies both one-to-one and onto. Now see the second example. Here also some arbitrary elements I am taking and giving arrow marks. Now you can observe that it is a one-to-one function because every distinct element has distinct image points. 1 has 0, 2 has 1, 3 has 4, 4 has 2. That means it is a one-to-one function. But it is not an onto function. What is the reason? Because 3 has no pre-image. You can see all 0, 1, 2, 4 is pre-image, but 3 has no pre-image. That means that function is not onto. And since it is not onto, we cannot say it is bijective. So it is also not a bijective function. Next, the final example. Now observe that this function, here all A1, A2, A3, A4 in the domain set has distinct image points. And every element in the codomain B1, B2, B3, 4 has pre-image. That means it is one-to-one and also onto. That means it is a bijective function. And if you know the concepts of one-to-one and onto function, it is not difficult to check bijective function. If it satisfies both conditions of one-to-one and onto function, then it is a bijective function. So watch my short tricks to check one-to-one function and short tricks to onto functions. Then you can check easily how to check one function bijective or not. Now there is an important note. If A and B are finite sets, okay, here we are discussing about only finite sets, not about infinite sets like real number, natural number. Finite sets only we are discussing here. And f from A to B is a bijection. That means two finite sets given, and f is a bijective function between two finite sets. Then A and B have the same number of elements. And this is an important note for bijective function. If you are getting a mapping from A to B and that mapping is bijective, then they must have same number of elements if two sets are finite. And you can observe these examples. In first example, we have taken B has less elements is comparison to A. So in this case, that function is always not one-to-one. And in second example, we have taken A has less elements is comparison to B. So in this case, you will get not onto. But in the final one, when it is bijective, the necessary condition is must have same number of elements. Otherwise, that function is not bijective. Bijective function appears if both sets have same number of elements, if they are finite sets. Understood the concepts? Now we will discuss the trick how to find out number of bijective functions between two finite sets. And it is an important powerful trick. Using this trick you can solve one question in 5 seconds. If A and B are two finite sets and F is a mapping from A to B which is a bijective function, and set A and set B contains n number of elements, note that both set contains n elements, and I told if it is a bijective function then they must have same number of elements. That means here you have to understand both A and B contains n number of elements. Then what is the trick? The number of bijective functions from set A to set B is n factorial. That means how many elements given, only we have to find its factorial to get the number of bijective functions. So now we will solve that question. Number of bijective functions from a set A of 10 elements to itself. That means that question is given from set A to set A only, and it contains 10 elements. Both A, it is mapping from A to A, and both set contains 10 number of elements. Then what is the trick for bijective functions? I told that it is n factorial. That means when it is n is 10 given, so the number of bijective functions is 10 factorial. Simple. That means which option is correct? Option B. So for such type of more tricks, subscribe my channel if you have not subscribed, and also like, comment and share my channel to get such type of more tricks and more solutions using such tricks for IIT-JEE problems and also other competitive examination problems. Thank you.